So today we're going to look at dividing fractions. We've been practicing writing fractions in mixed form and in improper fractions, and then we practiced multiplying fractions on Tuesday. But today we're going to start looking at the process of dividing fractions. So we've already done the do now, and we've gone over the homework. So we're going to look at some models to help visualize what it's like to divide a whole number by a fraction. But first we're going to look at just some basic division problems and see if we can see any patterns. So for these problems, we are not solving them, we are converting them from a division problem to a multiplication problem. So let's take a look at set 1, and I have 8 divided by 2. So how can I rewrite that as a multiplication problem? Well, let me give you an example. I would argue that this is the same as 8 times 1/2. Now, I want you to think about that a little bit and see if that makes sense to you. So 8 divided by 2, I think we all know, is 4. 8 times 1/2. If we do our usual fraction multiplication, we'd have 8 on top, we'd have 1 times 2 on the bottom, and that would give us 8 over 2, which is also 4. So I hope you can see that these two are the same problems. All right, let's look at the second one. We can rewrite this as 7 times 1 over 2. We can write the third one as 6 times 1 over 2. And the last one, of course, is 5 times 1 over 2. Again, I'm hoping you can see that these are equivalent problems. Now let's take a look at set 2. It's a little bit different. So we know that 6 divided by 6 is 1, but how can we write that as a multiplication problem? So I'm going to do kind of the same process and see if you agree. Do you agree that this is the same thing? And again, think about what you know about fraction multiplication, where we multiply the top and multiply the bottom, and I think you'll see that we get the same thing. Same deal with 5 divided by 5. It's going to be 5 times 1 over 5. Again, that's going to give you a 5 over 5, which is also equal to 1. Now 1/2 divided by 1/2 is a little bit different, so let's think about what this would look like. I argue that this is the same as 1/2 times 2 over 1. Where I've kind of flipped that second fraction. But again, think about what you know about fraction multiplication. If I multiply the tops and multiply the bottoms, I'm going to get 2 over 2, and that's the same as 1. Alright, let's look at 1/4. And again, I'm going to argue that this is the same as 4 over 1. Again, we know that when we divide a number by itself, we always get 1. And when I multiply these two numbers, I'm also going to get 4 over 4, and that's also going to be 1. Alright, let's take a look at some other examples. So I'm going to turn each of these into multiplication problems as well. So I'm going to write 12. Try it again. 12 times 1 over 6. I'm going to write this as 12 times 1 over 4. I'm going to write this as 12 times 1 over 3. And I'd like you to pause the video and fill out the rest of the table. And let's see what you come up with. Alright, so let's see how you did. You should have written something like 12 times 1/2, 12 times 1 over 1, which is kind of a weird expression, but it's correct. But then let's see what you came up with these. Alright, there's definitely a pattern there of kind of flipping that second fraction so that you get the same answer. Alright, so we're going to look at some models next that might help make this clearer. So let's take a look at those now. So let's take a look at this problem. Avery's father donated 6 gallons of paint to her school. That's, of course, an important number. The teachers at Avery's school have decided to paint tabletops with the paint. It will take 1/5 of a gallon to cover a small size table. It'll take 1/4 of a gallon to cover a medium sized table, and 1/3 of a gallon for a large size table. Let's take a look at question 1. How many small size tables can the teacher paint if they use all the paint? So I only need 1/5 of a gallon to cover a small size table, so each of these boxes below represent 1 gallon of paint. So I only need 1/5 to cover a small table. So let's put 1/5 of a box in here. So it's going to look something like this. And let's make sure I get the right size here. So hopefully I'll measure this out correctly. So there's 1/5 of that box, and that really represents one small table. So how many tables can I paint with a gallon? Well, I can paint 5 because I only need 1/5 of a gallon to paint one small table. That means I can get another 1/5 in. Another 1/5 in. And again, each of these represents one table. There's another 1/5. And my last 1/5. Okay, my sizes aren't perfect, but hopefully you can see the point that I can cover 5 small tables with 1 gallon of paint. Alright, so I have 6 gallons, so I can continue to paint small size tables. So here's another one, and another. And another. All right, there's 5 more tables. And I can do this for all of the 6 gallons, each gallon covering 5 tables. So the question is, how many small tables was I able to paint with 6 gallons? And you could count these up. I have 5, 10, 15, 20, 25, 30 small tables. And then the question is, write a division number sentence that relates to your model. Well, that sentence could look something like this. I've taken 6 gallons and divided it into fifths, and I've come up with 30 separate pieces. Let me say that again. I've taken 6 gallons, I've divided by 1/5, and found that there are 30 of those taken up by those 6 gallons. All right, let's keep that in mind and look at question 2. So we're now focusing on medium tables. And medium tables can be covered by 1/4 of a gallon. So now we want to divide each gallon into fourths, which means I can paint 4 tables per gallon. So let's do that. I'm going to, again, try to estimate what a fourth would look like. And see if I can get that in the corner there. All right, let's see how I did. We're going to copy that. And I've covered that 1 gallon of paint. I can paint 4 medium-sized tables. So let's do that for the rest of the tables. And then the question becomes, write a division number sentence that relates to your model. Again, how many medium-sized tables am I able to paint? So the first gallon I have 4, then I have 8, then I have 12, then I have 16, then I have 20, then I have 24. So that's a total of 24 tables. So I have taken 6 gallons and divided by 1/4. Again, how many fourths can I go into 6? And found out that my answer is 24. All right, let's take a look at question 3. All right, so now we're looking at the large size tables. And we know that it takes 1/3 of a gallon to paint 1 large size tables, which means for a full gallon, I can paint 3 tables. So I've gotten this started for you. I want you to pause the video and finish the rest of this and come up with the statement here for writing a division statement. All right, so pause for a second to complete this problem, and then we can see how you did. All right, let's see how you did. You can see by dividing each table into thirds that we end up with 18 tables that we can paint with 6 gallons, and here we have our equation, and hopefully that's what you got. Now let's take a look at another problem that's similar, and I'm going to have you do a lot of this on your own, so let's take a look at that one. So for this problem, Stella is starting a flower garden. She has 5 whole bags of potting soil to begin her garden. It will take 1/8 to fill a small size flower pot, and 1/6 to fill a medium-sized flower pot. And we're dealing with 5 total. So let's look at question 4. How many small-sized flower pots can Stella fill if she decided to do all small flower plots? So I want you to pause the video and try this, but let me give you a start. You're going to be dividing this up into 1/8. So I'm going to do, there's 2, there's 4, and there's 8. So that might give you an idea of how you can get this started. So again, pause the video and finish the rest of this problem, and then we'll see how you did. Alright, let's see how you did. You can see that if you divide each bag of potting soil into 8ths, that you can then fill 40 small-sized flower pots, and we can write the equation that 5 divided by 8ths equals 40. Alright, so let's take a look at the last version of this problem that we're going to do. So now we're going to be working with medium-sized flower pots, and those are 1/6 of a soil bag to fill a medium-sized flower pot. So I want you to pause and try this, but let me get you started again. So I need to divide this into thirds, and then I can divide each of those in half to get 6 per bag of potting soil. So again, I want you to pause the video and finish this question up, and then we'll see how you did. Alright, let's see how you did. If you divide each bag into 6 to cover a medium-sized flower pot, you can see that you're going to be able to cover 30 of those flower pots. So we can write the equation that 5 divided by 1/6 is equal to 30. Now we're going to see if we can find some patterns in in the work that we've just done. So if you look at the answers to the problems from 1 to 5, I want to know if you see any patterns that we can use to figure out a process to divide a whole number by a fraction. And I want to bring your attention to this. We saw that 6 divided by 1/5 is equal to 30. And notice the 6 and the 5. We said that 6 divided by 1/4 is 24. And notice the 6 and the 4. And the same thing with all of them. We said 6 divided by 1/3 is equal to 18. Notice the 6 and the 3. We said 5 divided by 1/8 is 40. And we said 5 divided by 1/6 is 30. So I hope you can see that 6 divided by 1/5 is the same as 6 times 5 over 1. And this is the same as 6 times 4 over 1. And 6 divided by 1/3 is the same as 6 times 3 over 1. And 5 divided by 1/8 is the same as 5 times 8 over 1. And finally, 5 divided by 1/6 is the same as 5 times 6 over 1. So you may see a procedure here that when you are dividing a whole number by a fraction, you can turn it into a multiplication problem by flipping the fraction and multiplying. So that's really the main strategy here. So let's see if we can summarize this some way that let's do another quick example for you. If I have 7 divided by 1/4, I know that's going to be the same as 7 times 4 over 1, which is going to be equal to 28. Okay, now so go back to Google Classroom and take the lesson 2.3 assessment. That's just underneath the assignment where you got the link to go to this presentation, and take that quick assessment so I can see how you're doing. And then you can try the challenge problem that's in the packet, and if you happen to finish that, then you can start the homework for tonight. So, let me know if you have any questions.